Today we are going to focus on one specific aspect of exponential function, which is the graphing part. Now, if I may have your attention, I just want you to understand something very simple, okay? Now, let me ask you this, okay? There's some empty space right here. Well, actually, let me just go ahead and ask you something here. What is 2 times 2? And what is 2 times 2 times 2? 8, right? What is 2 times 2 times 2 times 2? 16. Can you see this is an exponential growth? Okay, we are multiplying the same number. Okay, and it gets bigger and bigger exponentially. Okay, and if I do it for one more time, multiply 2 for one more time, it becomes 32, right? All right, now. So when you let me go ahead and give you a little contrast on the other side here. What if you have 1/2 times 1/2? That will be 1/4. 1/2 times 1/2. Like think about if you have a half, go ahead, cut it into another half. You have a quarter. Now, what if you have 1/2 times 1/2 times 1/2? 1/8. 1/2 times 1/2 times 1/2 times 1/2 is equal to 1/16. And what can you see between these two groups of numbers? They're both multiplying, right? But one general trend I want you to see here, if the number is bigger than 1 and it keeps on multiplying itself, the numbers get bigger. If you have a fraction and the fraction keeps on multiplying by itself, it gets smaller. Okay? Now, I hope you understand this simple trend right here. Okay? And the exponential function was actually very useful during the pandemic because one thing to evaluate the potency of how infectious the pandemic was, it's to use something called the R0 or R0, which is the meaning of R0. It's how many people one person can infect. Okay, if this number is bigger than 1, we've got a problem. Because that means we're going to have more and more people getting infected. If we can do something to suppress this number to become a number less than 1, then we say, all right, that's good. All right, so I think COVID, at one time, the R0 was definitely above 2, meaning that one person can make at least 2 people infected. And that's why the pandemic spread so easily and quickly back in the days when there were no any kind of preventive measures. All right, now let's go ahead and take a look at these 2 graphs. Okay, now I'm going to put 1, 2, 3 right here. Okay, I'm going to leave some space right here for the moment. I will start 1, 2, 3 right in the middle. So x is the exponent. What's 2 to the first power? 2 to the second power? And 2 to the third power? All right. All right, so you can put these numbers on put these dots on the graph. 1, 2, 2, 4, and 3, 8. Right? Now I'm going to work backward. Well, because 2 to the first power is? 2 to the first power is? 2. Oh, thank you. I was blind. Thank you. All right, now what about 2 to the 0 power? Now, this is a question that always gets people in the beginning. 2 to the first, 2 to the 0 power is 1. 2 to the 0 power, it's 1. Now, if you say, hey, Mr. Chan, I forgot about the reason why it's 2 to the 0 power, it's 1. Let me go ahead and remind you this. Do you still remember the exponent properties when you have a to the m over a to the n? Do you remember this? What is that equal to? A to the what power? M minus n, right? Or if I give you some example, it'll be like a to the third power over a square. Well, if the meaning is this, right? That's a meaning, and that's why we say, oh yeah, you just go ahead and cancel things out, so you have a to the first power. So you can reason that, oh yeah, it's the subtraction of exponents. So far, so good? So now, what if I have a cube over a cube? That's equal to 1, right? And then if you use the understanding of subtracting exponents, that will be a to the what power? 0 power. All right. So if any of you here saying that, oh, Mr. Chan, I have no idea why anything to the 0 power is 1, that's the proof. That is the justification that you can easily show yourself. I would say I only got convinced about anything to the 0 power it's 1 because I worked this whole thing out. Okay, so I want you to think about this and imagine that you are going to explain to somebody why anything to the 0 power it's 1. That would be a good example to use. What about 2 to the negative 1 power? Do you remember what negative power represents? We did that like quite a few weeks ago at the beginning of term 3. Huh?
1 over 2.
1 over 2. Okay, if you still remember, negative power means the reciprocal. So if you have the exponent of negative 2, what is 2 to the negative 2 power? 1 over 4. All right, so something that reminds yourself is that when the exponent is negative, it does not mean the number becomes negative. Okay, and as a matter of fact, when you have a number, like a number 2 right here, whatever power it raises to, it will still be positive. So this is the graph, which is a graph that shows some sort of growth. It goes up, it increases exponentially. Okay, and we say the y-intercept is 0, 1. What's the asymptote right here? The asymptote right here, it's the horizontal asymptote actually. Okay, which is y equal to 0. So as the graph goes all the way to the left, it leans closer to the x-axis, which is y equal to 0. And we say it is a growth because it grows from when we look at the graph from left to right. It is definitely growing. The domain would be all real numbers, so negative infinity to infinity. Well, in pre-calc, you are going to use this interval notation, so that's why I want to get you into a habit of writing interval notation. And then the range, it goes from 0 to infinity. It cannot be 0, all right? It can be as close to 0 as possible, but it cannot be 0. And if you ever wonder, like, really, it cannot be 0? I would say you can go ahead and try this out using a calculator. Sure. Let me go ahead and add a new calculator. So if I say 2 to the power of, say, negative 100, what would that be? Okay, so if you know how to read this number, this is 7.88. 9 times 10 to the negative 31 power, which is like 0 point, and then 30 zeros, then 78886. So that's a very small number. So again, it will not become negative, okay, based on this very fundamental function without any kind of transformations, okay?